Hey class, and welcome to part 7 of Building Envelopes in HVAC. This time we'll be focusing on something pretty specific that has a really big energy impact. That's economizers. So just to review a variable air volume HVAC operation, you've got return air coming out of your space that's being sucked out of the building. Some of that's exhausted. A lot of that is mixed back in with your outdoor air, your ventilation air. That's your mixed air, which then gets supplied at, say, 55 degrees, that's your deck temperature, into the ducts throughout the space. And then right before it's pushed into the space, it might be reheated if heating is called for, or it'll just stay at that 55-degree temperature if cooling is needed. So that's a VAV with terminal reheat. And there are some things that we want to focus on in terms of outdoor air intake that can have a really big impact on energy. So say it's summer outside, right? We've got a very hot day, so it's 95 degrees outside. Coming out of our building, we've got a return air temperature of, say, 72 degrees. How much of that is going to be mixed? Well, we want to really limit the amount of outdoor air that we're taking in, right? Close most of these dampers as much as possible, but that we still need to take in maybe 30% outdoor air for ventilation. People need fresh air. So our mixed air temperature is going to be around 80 degrees, right? It's going to warm up that 72 degrees a little bit, and we have to cool all of that down to meet our deck temperature requirements of 55 degrees. So that takes some energy. What about the winter? If it's kind of a mild winter day outside, say 30 degrees Fahrenheit, we've got a lot of return air coming back. We can mix these two air streams and try and match that 55-degree temperature, so we don't have to use either our cooling coil or our heating coil and just reach that nice 55-degree temperature. If it's 0 degrees outside, super cold, and our mixed air is, say, at 45 degrees, then we're going to need to use our heating coil, our steam coil perhaps, and reheat that to 55 degrees so we can deliver that throughout the rest of the building. Right, we still are going to be delivering air to the zones in this situation probably at 85 degrees, but we're doing the rest of the reheat at the terminal unit so we can take all the humidity out of the air at this point. All right, but say it's spring or fall or early in the morning on a summer day, and you've got 72-degree return air, and it's 60 degrees Fahrenheit outside. How much outdoor air should we be bringing in, right? Because eventually we need to get it to 55 degrees. Well, what you could do is just completely shut off that return air, right? Block that out and use 100% fresh outdoor air, because all that our return air is going to do is increase this mixed air temperature, right? And it's going to be more energy to cool it down. So that's what an economizer is. It's kind of a control method to use the free cooling of the outdoor air when it's available. And so anytime the outdoor air temperature is between, say, 55 degrees to 70 degrees Fahrenheit, that's still going to be less than our return air. And so we want to use this basically free cooling, because it's going to be a little bit cooler, 100% outdoor air into the space, because it takes less energy to meet our deck temperature. That's what an economizer is in terms of an HVAC air system. The actual components required to make it happen are, one, you have to make sure the outdoor air damper can accommodate 100% outdoor air. Sometimes the outdoor air vent might be too small if it was just sized for ventilation and not for full conditioning of the space. So look at the outdoor air damper control and positions available, usually in the cut sheet of the rooftop unit. It also needs a temperature sensor to engage those damper louvers as needed when conditions are right. The next piece is that sensor has to tell the brain what to do with that, right? We need control logic. And that's a little bit opaque. It's hard to see. This is what a controller looks like for a building at the U of I campus. And a whole bunch of logic is built into it just for the economizer to figure out, okay, what's the outdoor air condition? What's the humidity at? are we going to be using more or less energy based on bringing in more or less outdoor air? One big component within this control logic is a lockout temperature. And this is something that the building operator usually has a fair amount of control over. Now, that lockout temperature is to make sure that above 70 degrees, say even 75 degrees, we're not bringing in 100% outdoor air, because otherwise our outdoor air supply would be have a larger energy impact than mixing in some of that return air. So sometimes that lockout temperature is all the way down to 65 degrees or 60 or 55. And in that situation, you're losing a whole lot of free cooling that is possible. So that's one thing to just ask during an energy audit is, what is the lockout temperature of your economizer? It really should be close to what the return air temperature is going to be in that zone, close to that 72 or 70 degree air temperature. If it's not, if it's down at 55 or 60, you're not getting a lot of energy savings from the economizer. It's not optimized, and it's one big component that can save up to 10% of a building's HVAC energy, which has a really big impact. All right, that's Economizers in a nutshell. I look forward to seeing you guys next time.